Hello, my geometry students. It is day 1 of Unit 6, and we are starting right in with some triangle properties, specifically Pythagorean theorem for right triangles. So I know you know what it is. A squared plus B squared equals C squared. The important thing to know here, A and B have to be the legs of the right triangle, so the perpendicular parts, and then C has to be the hypotenuse for this to work. All right. So let's get started. The very first one, what I would suggest, always just take a moment and label. So the side opposite the 90, we know that's the hypotenuse, leaving the 2 and the 6 to be the legs, the A and the B, which you can label interchangeably. So 2 squared plus 6 squared equals x squared. 4, 36. And then when we add these together, we can take the square root. It's a simplest radical form. So we saw some practice with this in the last unit. Biggest perfect square would be 4. 10 would be my leftover, if you will. And then we end up with 2 radical 10. That should be the answer to the very first one there. Whereas 1b, there is an x missing. So fill in an x right there. Opposite the 90 is my hypotenuse, and then a and b. And so when we set this up, it should be x squared plus 15 squared and then equals 17 squared. If the numbers are so big that you don't know the perfect squares, have your calculator handy nearby so that 15 squared is 225, 17 squared is 289, and then subtract on over that 225, because x can be the hypotenuse or it can be one of the legs. So when we take the difference, we're left with 64, which that comes out nice and pretty as x equaling 8. So right here, this is an example of something called a Pythagorean triple, which means you have 3 nice whole numbers that make the Pythagorean theorem true. So 8, 15, and 17, you can plug in and can be the side lengths of a right triangle there. Ooh, you can see some nice sunshine happening in my room here. I'm going to slide on up. Number 2. Number 2, I like this one. Hypotenuse. So that's the x. Here's A, here's B. All right. When we plug in that quantity x minus 2, I want to square all of it. So squared plus 4 squared and then equals x squared. So when we have something like this, to square that out, we need to do a little box multiplication. You can do it off to the side, wherever works best. Maybe I'll do over here. So this is x minus 2 times x minus 2. Oops, sorry, I'm a little off the screen there. X squared minus 2x, and then plus 4. So that this will give us x squared minus 4x plus 4, and then keep on going with the equation. 4 squared is 16. X squared will just stay x squared here. Okay, when we combine our like terms, I get x squared minus 4x plus 20 equals x squared. So I was just combining those. And then when you move this x squared over, they cancel right out. So it actually ends up a fairly simple equation. And so now I can just add that 4x to the other side, divide by 4, and x comes out as 5. So when you look at the triangle itself, if I go back in, x is 5, and then x minus 2, 5 minus 2, that would come out as 3. So 3, 4, 5, that's another Pythagorean triple. 3 nice whole numbers that make the Pythagorean theorem true. All right, we're going to hop around a little bit on these next pages. So on to the next page, we're actually going to skip example 3 at the top. We'll save this guy for a little recap for class. Slide on down to number 4. So number 4 here, it's still the same concept, the hypotenuse opposite the right angle, and then we have our A and B. But I wanted to do this one because of that radical there. So when we go to set this up, we have x squared plus 6 squared and then equals 3 radical 5 squared. I would highly recommend, whoops, I'm a little bit in the shadow there. If I got like a really strong sunlight coming through the window right now. Highly recommend putting some parentheses around that 3 radical 5 when you go to square it. Because 6 squared we can do in our head, 36. If it's easier, grab your calculator, right? And then what we can do, breaking that up a little bit, is we can do in parentheses 3 radical 5, close up the parenthesis, and then square it. When we do that, we end up with 45. Right? If you don't put the parentheses around it, it will give you a different answer, which is incorrect. So make sure parentheses and then square it. Then from here, we can subtract 36. That'll give us a difference of 9. And then this one's nice and easy to finish on out, right? Something to keep in mind. We know that when we take the square root, it's technically the plus or minus, but because it's a side length, I don't even need to consider that negative. We can just say x equals positive 3 here. That's it. All right, on to page 3. Again, you have some that are actually for practice. I want you to try these ones on your own. If you get stuck, at the very least, set them up. So try number 5, try number 6, hold on to number 7, right? So you don't have to do this one. So try 5, try number 6, and I'm going to want to know what you got for your answers for those two. So make sure that you actually do them. And then jump on over to page 4. All right, on page 4, there are 2 that are multi-step ones here. So what you are given is you have a right triangle where the legs are 7 and 9, and then you have a second right triangle kind of attached to it here where the legs are x and 10. So to be able to solve for x, what we first really need to figure out is what the length of this segment is right here, or the hypotenuse of the triangle on the left there. So if we focus on this, and I'll call it y, so I have a variable to use here, that would be the C of my ABC for this little triangle right here. So let's try it. If we go 7 squared plus 9 squared equals y squared, or you could have used c squared, that would be fine too. We get 49 plus 81. We do 49 plus 81. We get 130 equals y squared. So then y would just be radical 130. Now, 2 things. I don't really think that's going to simplify, but I don't need it to because it's not my final answer. Now what we can do is we can focus on the triangle that has the x in it. If I focus on this triangle, 10 and x would be my a and b values. And then the y that we just found, that's also the c because it's the hypotenuse of that little red triangle. So in my red triangle, when I go to do a squared plus b squared equals c squared, I would have 10 squared plus x squared, and then equaling my y value, which was radical 130 squared. Here's the nice thing that happens here. 100 plus x squared, square root and a square, we've talked about this. They cancel right on out. So I'm just left with regular old 130. Subtract 100. So the x squared comes out to be just 30 all by itself. And then when we go to take the square root, you always want to leave it in simplest radical form. Well, there are no perfect squares that are a factor of radical 30. So that is actually as far as it can go. That should be my answer for x right there. All right, you have one last one to look at, and that is number 2. So when we slide on up here, again, there's multiple things going on here. We've got a little right triangle on the right. We've got a right triangle on the left. To be able to find x, we have to start with the right triangle on the right-hand side. So we know one of the legs, so like the A, we know the hypotenuse, the C. We need to figure out what's the B value here. So I'm going to call that y right there. So let's start with that. We can do 8 squared plus y squared equals 10 squared. So we get 64 plus y squared equals 100. Subtract that 64 over, we get y squared equals 36. This is going to come out nice and pretty. So y is equal to 6. All right, well, how is that helpful? Well, if I know the full length is 20 and I know this piece of it is 6, then this remaining part is just 20 minus 6, or 14. So now that I know that length, I know this is 8. In my triangle on the left, here would be my A, my B, and then my hypotenuse of C. All right, try it out. 8 squared plus 14 squared equals x squared. So this will be 64. 14 squared is 196. And then if we do 64 plus 196, we get 260. All right. Simplifying that radical. Probably not a whole lot that's going to happen here. If I go into my y equals, I can type in 260 divided by x and go see if I see any perfect square factors. Yeah, right here, I actually have 4 and 65. I think that might be as good as it's going to get. So I could break this into radical 4 times radical 65. And my answer then would be 2 radical 65 for the value of x in simplest radical form. All right, that's it. Please make sure that you tried numbers 5 and 6 on your own so that you are ready to talk about them tomorrow in class. Thanks for watching, guys.